This cutting-edge stealth aircraft completely transformed what it means to control the skies. The F-22 Raptor stands as one of humanity's greatest engineering achievements, pushing stealth technology and thrust vectoring capabilities far beyond anything that came before it. The aircraft carries an enormous price tag, but the sophisticated systems it brings to the table make it a worthwhile investment for the air dominance it delivers, in response to a growing demand for a next-generation air superiority fighter. The U.S. Air Force launched the Advanced Tactical Fighter program back in 1981. The primary objective was establishing uncontested control of the skies, driven by the threat posed by rival aircraft like the Soviet MiG-29 and Su-27. Two defense contractors, Lockheed Martin and Northrop Grumman, were selected in 1986 to participate in a demonstration and validation phase, during which each company built a competing prototype, the YF-22 and the YF-23 respectively. The YF-22 was Lockheed's entry, while the YF-23 represented Northrop's vision. The YF-22 was considered to have the edge in terms of agility and overall maneuverability. The YF-23, by contrast, offered superior stealth characteristics and a better thrust-to-weight ratio, but it lacked thrust vectoring capability. In the end, the YF-22 was chosen as the winner. It went on to become the F-22 Raptor, the world's first fifth-generation fighter jet. Low-rate initial production began in 2001, and full-rate production approval followed in 2005. The F-22 delivered on the requirements set out by the ATF program, most notably through its remarkably low radar cross-section. The Raptor's frontal radar cross-section is reported to measure around 0.0001 square meters, smaller than the radar return produced by an insect. This extraordinary achievement is the result of two key elements: the carefully engineered shape of the airframe and the application of radar-absorbing material, commonly referred to as RAM. As the name implies, these materials absorb the electromagnetic energy of incoming radar signals, dramatically weakening the reflected return. The F-22 uses a polymer-based radar-absorbing coating applied across its entire external surface. While stealth keeps the aircraft hidden from enemy sensors, thrust vector control gives it unmatched agility at every stage of flight. The fighter is equipped with two-dimensional thrust vectoring nozzles capable of redirecting engine thrust along the aircraft's pitch axis. These convergent-divergent nozzles can pivot up to 20 degrees in either direction to manipulate the direction of thrust. The thrust vectoring system is fully integrated into the aircraft's flight control architecture and managed automatically by the Full Authority Digital Electronic Control System, known as FADEC, without requiring direct pilot input. At low speeds and high speeds alike, where conventional flight control surfaces begin to lose effectiveness, thrust vectoring steps in to maintain precise control. In essence, it functions as an additional set of control surfaces, particularly valuable during high-demand maneuvers and post-stall flight regimes, where standard surfaces are simply no longer capable of generating the needed aerodynamic forces. Beyond these remarkable capabilities, the F-22's weapons systems are arguably its most critical asset. The Raptor can carry a wide variety of armaments suited to both air-to-air and air-to-ground mission profiles. In an air-to-air configuration, the aircraft carries 6 AIM-120 radar-guided missiles within its main internal weapons bay. 2 additional AIM-9 Sidewinder missiles are housed in the 2 smaller side bays. When configured for air-to-ground operations, the main bay holds 2 1,000-pound GBU 32 JDAM precision-guided bombs alongside 2 AIM-120 missiles, while the Sidewinders in the side bays remain in place. The Raptor can deliver any of these weapons on-axis or off-axis, whether diving, flying level, or in a lofted trajectory, at virtually any altitude. This combination of stealth, agility, and precision firepower gives the F-22 the advantage of a first-kill opportunity while allowing it to strike heavily defended targets with minimal exposure to surface-to-air threats. For situations requiring a closer engagement, a 20mm M61A2 Vulcan Gatling gun is recessed into the fuselage as a last resort weapon. The aircraft draws its remarkable performance from 2 Pratt & Whitney F119-PW-1100 engines, together generating 70,000 pounds of thrust. During takeoff, the thrust vectoring nozzles channel this power to achieve a steeper pitch angle and a noticeably shorter takeoff roll. Thrust vector control also improves the aircraft's roll rate by nearly 50%. The Raptor's reported climb rate of 62,000 feet per minute is a staggering figure, one that severely compresses the engagement windows available to both surface-to-air and air-to-air threats trying to track and lock onto the aircraft. The F-22 generates more raw power than any other fighter currently operated by the U.S. Air Force. Its high thrust-to-weight ratio, where total engine output exceeds the aircraft's typical operating weight, means it can continue accelerating even during a vertical climb. The aircraft also features comparatively low wing loading relative to other fighters of its generation, which translates into excellent maneuverability at lower speeds and the ability to execute tight, aggressive turns. In addition to its raw agility, the F-22's survivability is further reinforced by its supercruise capability. The Raptor can sustain flight speeds above Mach 1.5 without engaging its afterburners, keeping its infrared signature at a low and harder-to-detect level. The ability to fly fast while maintaining stealth creates the ideal conditions for a surprise engagement. The enemy may not know the aircraft is there until it's already too late. As the premier fighter in the U.S. military's inventory, the F-22 must also be capable of operating in dispersed and austere conditions. The aircraft is designed to function from damaged or remote airstrips where conventional ground support infrastructure may not be available. To address the challenge of refueling in these environments, the U.S. Air Force developed the STAR system, a self-contained refueling platform that can support fighter operations in remote locations. The system delivers fuel at a rate of 300 gallons per minute and is considerably easier to operate than traditional refueling setups. The availability of STAR kits strengthens the military's agile combat employment strategy, improving readiness against unforeseen and rapidly evolving threats. When it comes to maintaining the F-22, the stealth coating and weapon systems demand the most attention. Even minor damage to the radar-absorbing surface can significantly degrade the aircraft's low observable characteristics. The intensive upkeep required by the stealth coating system contributed to a notable drop in mission-capable rates, which fell to around 50% at certain points. When coating damage is detected, maintenance personnel sand and clean the affected area before reapplying the base radar-absorbing coat, followed by a protective top coat over it. To manage the sheer scale of this maintenance requirement, the Air Force has introduced robotic systems to apply the radar-absorbing coating. These robots are particularly effective on the complex, curved surfaces of the serpentine engine inlets, the area most vulnerable to coating wear and the most difficult section for human painters to access and treat properly. Weapons system maintenance receives equally careful attention. For the M61A2 Gatling gun, the gun firing log serves as the starting point for any maintenance assessment. Technicians review the log, which tracks the cumulative number of rounds fired during each flight to determine what level of maintenance is required. Routine tests such as torque wing fasteners and replacing breech bolt assemblies are carried out at defined round count intervals. Once the total round count reaches 120,000, the gun is removed from the aircraft entirely and sent to a depot-level maintenance facility for a more comprehensive overhaul. Despite being the most capable fighter jet in existence, operating the F-22 comes with significant practical challenges and costs. Financial burden is the most prominent concern. The Raptor's operating cost runs above $80,000 per flight hour, compared to the F-16, which costs just under $30,000 per hour. Meanwhile, the broader direction of global military aviation was shifting toward multi-role fighters, platforms that offer greater flexibility at a lower cost. This shift gave rise to the Joint Strike Fighter program, which produced the F-35 Lightning II, a technologically advanced aircraft designed to fulfill multiple mission roles at a more manageable cost. The F-35 Lightning II incorporates stealth capabilities comparable to those of the F-22, while also featuring advanced sensor fusion, an integrated electronic warfare suite, and sophisticated avionics, tailored to its multi-role mission set. The arrival of the more adaptable F-35 further expanded the U.S. military's ability to conduct dispersed operations without depending on centralized basing infrastructure. In the context of agile combat employment, aerial refueling is essential, and the F-35 is well equipped in this regard. Of the three variants, the F-35A receives fuel through a flying boom system, while the F-35B and F-35C variants use the probe and drogue method. The F-35's versatility also extends to close air support, where it can engage and assist ground forces directly. It carries an internal GAU-22 a 25mm Gatling gun capable of firing at 3,300 rounds per minute. And it can deliver precision high-explosive munitions, such as GBU-31 Jessie-DA-Ms, against high-value targets. As capable as the F-35 Lightning II undoubtedly is, the unique combination of stealth, agility, raw power, and maneuverability that defines the F-22 Raptor gives it the potential to outclass any fighter aircraft currently flying. This makes the Raptor's role in modern air-to-air combat not just relevant, but absolutely irreplaceable. That's all for this video. If this is Smaden, we hope you found it worthwhile. Make sure to subscribe so you don't miss any upcoming content, and we'll see you next time.